The final thing that we're going to look at today is combinations of transformations. So sometimes we're not just transforming a function in one way, but we have 2 or 3 or even more transformations to do to the function. The important thing to remember here is that you must go in order. Okay, you cannot just do your favorite transformation first. You must go in the order that you see them. So let's read all of these transformations and figure out how many we have and what order we need to do them in. So it says that g of x, we are going to do a horizontal stretch by a factor of 2. So horizontal stretch by a factor of 2. Then we are going to translate by 1 unit down. So that's going to be a vertical transformation, a translation 1 unit down. And then finally followed by a reflection in the x-axis. So let's go ahead and highlight reflection in the x-axis. So it looks to me like we have 3 different transformations. I'm going to go ahead and number them. I'm going to call this one number 1, and I will call the next one number 2, and finally we have number 3. All right, our final transformation is supposed to be called g of x. So these kind of intermediate transformations, I'm just going to pick another letter of the alphabet. I'm going to stay close to F and G and just go ahead and pick a number or a letter to designate my first transformation. So my first transformation, we'll just go ahead and label it number 1, and I'm going to call it h of x. We've already used F and G, why not use H? And so H is going to be a horizontal stretch by a factor of 2. Remember that a horizontal stretch, that factor of 2 is 1 over a, so I'm going to actually write 1/2 x, so f of 1/2 x, to indicate the horizontal stretch by a factor of 2. Now, we started with the parent function of just x squared, so I'm going to plug that in, and remember that the 1/2 goes with the x, so 1/2 x is going to go inside a grouping symbol. The squared needs to go outside because we have to square both the 1/2 and the x. Now, let's go ahead and look at the second transformation. So the second transformation, I'm just going to call it j. I's look too much like 1, so I'm going to skip I and go to j. So j of x now, we're no longer starting with our f of x. We're going to start with our h of x, our function that has already been transformed, and we need to translate it 1 unit down. Remember that that is just a number tacked on the end. So it's going to be our h of x function, and then because we're going down, it's a -1. So now h of x is 1/2 x squared, and then we tack on the -1. Finally, we are down to our last transformation, transformation number 3. We will call that g of x. G of x is a reflection in the x-axis. So a x-axis reflection goes out in front, and it's going to be a reflection on our j of x function. What is our j of x function? Well, it's this right here. So we are going to use that as our j of x. So this is going to be equal to negative, and then I need to put this entire thing in a big old set of parentheses. We're going to have negative 1/2 x squared minus 1, and then I'm going to close up that big parentheses. We're not quite done because we've got double sets of parentheses. We need to fix that a little bit. We can still leave that 1/2 x in parentheses because that's separating it from the squared, but we do want to go ahead and distribute this negative. And so we can say finally that g of x is going to be negative 1/2 x squared, and then don't forget to multiply the negative times the -1, which is actually going to end up giving us a +1. And that is our function that started with a simple x squared here and ended up as this transformed function after being transformed 3 ways.